Continuation of the previous video. Today we're going to learn some aspects related to mass media and society. So let's have an introduction. Mass media plays a central role in shaping and reflecting the values, beliefs, and behaviors of society. It encompasses various forms of communication that reach a large audience, including television, radio, newspapers, magazines, and internet and social media. This symbiotic relationship between mass media and society has far reaching implications. And role of mass media, informative role. Mass media serves as a primary source of information, offering news, analysis, and educational content to the public. It keeps individuals informed about local, national, and global events as well as scientific discoveries, social issues, and cultural developments. And agenda setting. Mass media has the power to influence the public agenda by determining which topics and issues are given prominence in news coverage. Through its choice and reporting, it shapes public discourse and opinion. An educational role. Educational programs and documentaries on television, radio, and online platforms contribute to learning and knowledge dissemination. Mass media extends access to education beyond traditional classrooms. And entertainment. Mass media provides entertainment content in the form of movies, television shows, music, and sports. This offering serves as a source of relaxation and enjoyment for individuals. And advertising and commercial role. Mass media is a crucial platform for advertisers to reach their target audience. It generates revenue through advertising, which in turn supports media organizations. Then, social cohesion. Media outlets promote social cohesion by fostering a sense of shared culture and identity. Television, films, and music often reflect societal values and norms. Then, influence of mass media on society. Information of formation of public opinion. Mass media plays a significant role in shaping public opinion on various issues. Its reporting and editorial choices can influence public sentiment and political decisions. And cultural transmission. Media is a primary vehicle for transmitting cultural values, norms, and traditions. Through proper culture, it influences lifestyle choices, fashion trends, and consumer behavior. Then, socialization. Mass media contributes to socialization of individuals, particularly young people. It can shape their perceptions of gender roles, societal expectations, and moral values. Then, agenda setting and framing. Media outlets have the power to set the agenda by highlighting certain issues while downplaying others. The framing of news stories can influence the interpretation of events. Then, crisis communication. During crisis management, mass media provides critical information and updates to the public. It can contribute to public safety and emergency response. And challenges and concerns related to this media bias. Concerns about media bias, whether political, corporate, or ideological, raise questions about objectivity and impartiality in reporting. Then, sensationalism. Some media organizations prioritize sensational stories to boost ratings or readership, potentially at the expense of more substantial, subs- substantial news. Fake news and disinformation. The digital age has brought challenges related to the spread of fake news and disinformation, which can have serious consequences for public trust and decision making. Then, privacy and surveillance. The use of mass media for surveillance and invasion of privacy raises ethical and legal questions regarding individual rights and liberties. And media ownership and concentration. Concerns about media ownership being concentrated in the hands of a few large corporations can affect diversity in news and perspectives. Then, media literacy. Media literacy is a crucial skill that empowers individuals to critically analyze and evaluate media content. It involves the ability to discern credible sources, detect biases, and interpret the messages conveyed by mass media. Then, conclusion. Let's have a conclusion. The relationship between mass media and society is dynamic and complex. Mass media influences society by informing, entertaining, and educating, while society in turn shapes the content and direction of the media. It's essential for individuals to engage with media critically, recognizing its potential impact and consequences. Understanding the role of mass media in society is vital for informed citizenship, ethical journalism, and responsible media consumption. Then, now we are going to learn some aspects related to mathematical reasoning and aptitude, very important portion. So here we won't be discussing problems related to this. That's a shortcoming of this lecture series. I take responsibility for that. We are just going to read some theoretical aspects of this mathematical reasoning and aptitude. So I prefer to watch other videos for practical application of these theoretical knowledge, and also take adequate measures to solve previous question papers too. Okay. First, mathematical reasoning and aptitude. Mathematical reasoning and aptitude are essential skills that go beyond simple arithmetic. They involve the ability to think logically, solve complex problems, and make decisions based on quantitative information. These skills are highly valuable in academia, various professionals, and daily life. And mathematical reasoning. Mathematical reasoning refers to the process of using logical thinking, analysis, and deductive reasoning to solve mathematical problems and draw conclusions based on mathematical principles. Then characteristics. Key characteristics of mathematical reasoning include critical thinking. We need critical thinking, precision, and systematic problem solving. It often involves the application of mathematical concepts to real world situations. Then mathematical aptitude, meaning mathematical aptitude is the innate or developed ability to perform mathematical operations and solve mathematical problems efficiently and accurately. Characteristics. Mathematical aptitude includes skills such as numerical fluency, problem solving, pattern recognition, and the ability to handle mathematical concepts at varying levels of complexity. Then applications of mathematical reasoning and aptitude. Academia. Mathematical reasoning is fundamental in academic disciplines such as mathematics, physics, engineering, and computer science. It underpins advanced research and problem solving. And business and finance. In fields like finance and economics, mathematical reasoning is used for statistical analysis, risk assessment, and financial modeling. Then technology and engineering. Mathematical reasoning is essential for designing algorithms, analyzing data, and solving engineering problems. Then healthcare. Medical professionals use mathematical reasoning for tasks such as drug dosage calculations, medical research, and analyzing patient data. Teachers and educators use mathematical reasoning to develop effective teaching strategies, design assessments, and help students grasp mathematical concepts. And types of mathematical reasoning. Deductive reasoning. Deductive reasoning in the sense that involve making specific conclusions based on general principles or premises. It follows a top-down approach, moving from the general to the specific. And inductive reasoning involves making general conclusions based on specific observations or patterns. It follows a bottom-up approach, moving from the specific to the general. Then abductive reasoning, a form of reasoning that aims to find the best possible explanation for a given set of observations or data. Then mathematical aptitude testing. Aptitude tests various standardized aptitude tests such as SAT, GRE, and GMAT include mathematical reasoning sections to assess an individual's mathematical abilities. Then psychometric tests. These tests evaluate an individual's mathematical aptitude, numeracy, and problem solving skills. They are commonly used in employment and education settings. Then challenges in developing mathematical reasoning and aptitude. Lack of mathematical confidence. Many individuals lack confidence in their mathematical abilities, which can hinder the development of mathematical reasoning and aptitude. Inadequate education. Inadequate or ineffective math calculation or education can leave individuals without the necessary foundation for developing mathematical reasoning skills. Math anxiety. Some individuals experience math anxiety, a fear of math related tasks that can impede their mathematical reasoning and aptitude. And I want to add one more point, which I personally experience, that is dyscalculia, something similar to dyslexia, where a person experiences difficulty related to numbers. So that is also another cause, and that is not something which we fake for the sake of something. That's an actual thing. Dyscalculia. I prefer you guys to search about that. Dyscalculia. Then developing mathematical reasoning and aptitude. Practice. Regular practice with mathematical problems and exercise can improve mathematical reasoning and aptitude. Problem solving. Actively engage in solving real world problems that require mathematical thinking. Then seek support. Seek guidance and support from educator or mentors to develop mathematical skills. Then online resources. Utilize online resources, tutorials, and resources to enhance mathematical reasoning and aptitude. So mathematical reasoning and aptitude are valuable skills that are applicable across various domains of life. Developing these skills through practice, education, and a problem-solving mindset can greatly enhance an individual's capacity to think logically, make informed decisions, and solve complex problems, ultimately contributing to personal and professional success. Then types of reasoning, for example, number series in particular, we are going to learn about that. Once again, I'm going to mention some theoretical aspects. You need to practice problems related to this with the help of other videos or charts or question paper sets, whatever it is. So types of reasoning, number series. Number series is a subset of mathematical reasoning that involves a systematic arrangement of numbers based on a certain rule or pattern. Understanding and solving number series is essential in various academic, competitive, and real-world problem-solving contexts. Arithmetic number series. In an arithmetic number series, each number is derived by adding or subtracting a fixed value known as the common difference to the previous number. For example, 2, 4, 6, 8, 10, where the common difference is 2. You know that. Arithmetic series exhibit linear growth or progression. Linear progression, where the difference between any two consecutive numbers remains constant. Then geometric number series. In a geometric number series, each number is derived by multiplying or dividing the previous number by a fixed value known as the common ratio. For example, 2, 4, 8, 16, 32, where the common ratio is 2. Characteristic geometric series exhibit exponential growth, where the ratio between any two consecutive numbers remains constant. Then square number series. In a square number series, each number is the square of the natural numbers in ascending order. Square number series where each number is the square of consecutive natural numbers. Square series increase with square of natural numbers. Then cubical number series. In a cubical number series, each number is a cube of natural numbers in ascending order, where each number is the cube of consecutive natural number. Cubical series increase with the cube of natural numbers. Then Fibonacci series. This is something which happens in case of the pattern of pineapple leaves, I guess. Yeah, same is the case with sunflower arrangement also. A pattern which nature follows, I guess. That is Fibonacci series. The Fibonacci series is formed by adding the two preceding numbers to generate the next number, where each number is the sum of the two preceding numbers. The Fibonacci series exhibits a unique pattern where each number depends on the two immediately preceding numbers. Then prime number series. In a prime number series, each number is a prime number, which means it has no divisors other than 1 and itself. No divisors other than 1 and itself, where each number is a prime number. 2, 3, 5, 7, 11, 13, 17, 19. Prime number series features numbers that cannot be evenly divided by any other number except 1 and themselves. Then quadratic or polynomial series. Quadratic or polynomial series involves complex equations and their solutions to derive the numbers in the series. 1, 4, 9, 16, 25, like that, where each number is derived from the equation n raised to 2. In characteristics, quadratic or polynomial series is characterized by numbers generated using mathematical functions. So let's have a conclusion. Understanding and solving number series is essential for enhancing mathematical reasoning skills. It requires the ability to recognize patterns, identify the underlying rules, and apply logical thinking to predict and calculate future numbers in the series. So number series problems often appear in competitive exams, IQ tests, and mathematical puzzles. The next letter series, which we are going to learn with the help of next video, but I'm going to start that. Letter series, also known as an alphabet series or letter sequence, is a subset of logical and analytical reasoning that involves a systemic arrangement of letters based on a certain pattern or rule. It is a crucial component of various competitive exams, intelligence tests, and logical reasoning assessments. So, letter series is a form of non-verbal reasoning that focuses on recognizing and deciphering patterns or relationships among letters. Success in solving letter series problems depends on the ability to discern these patterns and apply logical thinking to determine the next letter in the sequence. Thank you for listening. Yeah, and don't forget to practice application level questions with this. Thank you.